So Janta, welcome once again to my channel Puzzle Pandit. I am Manoj Ran Singh, and today I am here with another Sudoku variant. This one is known as Between the Eyes, and this is by Matt Tressel. Uh, this is the same guy who has created this Sudoku puzzle named Three Wishes. That was a miracle Sudoku, and that was really great. That was featured on many channels, including the CTC channel, and that was that was excellent. I mean, amazing puzzle. I mean, how you can have a miracle Sudoku. Miracle means the entire grid is empty without any clue or without any number, and then you only have the rule set with which you can fill the grid. Now, normally the rule set in Miracle Sudokus are quite complicated, but this rule set was really small, and yeah, you will be really amazed that you know how such small rule set can give rise to the entire feeling of the Sudoku grid. So that was a great puzzle. Three wishes. I'll put the link also in this description, and that was a very easy puzzle, guys. So give it a try. Um, uh, yeah, I really appreciated that how come people come up with such great ideas. But anyway, that is the same person who has created this, and this is Between the Eyes. This also has 95% rating on Logic Master as of now, and this is 3-star difficulty, that is medium difficulty. So let's start by reading the rules. So normal Sudoku rules apply. That means each row, each column, and then each 3x3 box contains the digit 1 to 9 only once without any repetition. Digits separated by V must sum to 5. So this V we are seeing here. So the digits should be here such that they should sum to 5. So if you have 2 here, you must have 3 here so that they can sum to 5. Digits separated by an X must sum to 10. So we see X's also here. Right? X here, X here, X here. So that means there are some the sum of these two digits should be 10. So if you have something like 3 here, then you should have 7 here so that the sum is 10. Digits along an arrow line sum to the digit in the attached circle, right? So we see this arrow. This is called as a arrow circle. So let's take this arrow. So now you should be placing digits on this arrow such that the sum of their digits should be placed in this circle. So something like this is 4, this is 3, and this must be 4 plus 3, 7. This cannot be anything. So that's all these circle arrows. So that's how the circle arrow goes. What else is there? Digit must not repeat within a marked digit, dark eye. Oh, right. So that is the between the eyes. So basically, this looks like an English letter I, this marked region, right? So hence between the eyes, I guess. So yeah, what should happen is that the digit should not repeat in these regions, right? So let's so for if I have 4 here, so I could not have 4 in any of these regions, and likewise if I have 7 here, I do not have 7 in any of these regions. Similarly, with this region, digits should not repeat. So yeah, with that, that's the rule set, kind of standard rule set. Even we have seen the region, the others are in standard V and X, some arrows, and even the region is infrequent, but still kind of standard rule set. So with that, yeah, you please give it a try to this puzzle. This is a good puzzle. I really liked. I have solved it once, but I am not sure whether I will remember the entire thing. I remember bits and pieces, but I'm not sure I will remember the entire process. But definitely, you should be able to try that. And if you're stuck somewhere, then you can come back, watch this video, and continue, or just watch the video for the fun of it, if you are getting fun from it. So yeah, just before starting the video, let me just repeat that if you have any puzzle or any puzzle or any problem that problem in the same math problem or a programming problem, something like that, which is generic, which you are not able to solve, let me know, and I'll be able to give it a try. And so sometimes what happens is that, for example, solving the Sudoku, we as a person solving that, you get some idea and you only concentrate on that idea, and then sometimes you do not look into the other direction. So that normally happens with me many times, that I stuck in some puzzle, but then when I look on other channels how those people have solved it, then I suddenly think that, oh, this could have done by this also, and why didn't I think of that? And that's clearly because I'm only thinking in one direction. And if you are solving the Sudoku, you must have seen that, right? Most of the times, that even after pencil marking, we forget to, you know, do some deductions, that reduce some numbers from a cell, just because we were concentrating on some area. So these kind of things happen. So just telling that if you have some puzzle which you are stuck with and you are not able to find solution anywhere, maybe I'll give it a try. So with that, let's try this puzzle. Right. So these areas are unique, and that means this is 1, 2, 3, 4, 5, 6, and 9. Right. So these both have 9 digits. That means these are kind of another house which only contains 1 to 9 digits without any repetition, like rows, column, and boxes. Uh, yeah, all right. So this thing, right? We have to look at this digit, right? Let's call this green digit. So where is this green digit here, right? Now this is some digit between 1 to 9. So it must occur in this box. So where is that green digit could come in this box? So now it is not this region because this is part of the region, right? So it is not in these cells. It cannot be in these cells because it's on the circle. So if it is on the circle, and imagine it is here, then the other two must be zero because all these sums should be the same as this. So that's not possible, and this is why Sudoku is not there. So all these cells are gone. That means the digit must be present here. Now where is this same digit here? Okay. Now we know that this digit is here and here. So by Sudoku it is not here. By the region logic it is not here, and then now this is also on the arrow, so it is not there. That means this must be here. Now where is this digit here? Right? It's not here by Sudoku. It's not here by the um, arrow logic, and it's not here by the region logic. So it's only present in one of these two. So now where it is here, right? Now again it is not here by the Sudoku logic, neither here, and neither here by the arrow logic. So that means it is only one of here. Okay. Now same thing we can do here. Now for that, then again we have to assume that these two are different. So the green is here. If, let's assume that green is here. So that means that is green, right? And let's call this as pink. So now same thing here, right? I mean same logic. If you apply the same logic, where is this pink digit um, here in this box, you see that it cannot be here with the region logic, it cannot be here with the arrow logic, and it cannot be here with the Sudoku logic. So that means it must be here. Again, where this is, this must be here because it cannot be here in this with the Sudoku logic, it cannot be here with the region logic, and cannot be here with the arrow logic. So it must be here. And now where it is in this box, so it cannot be here with the uh, Sudoku logic, cannot be here with the region logic, and cannot be here with the arrow logic. So it must be somewhere here. And now again where it is here, right? Where it is here, it cannot be here with the Sudoku logic, it cannot be here with the arrow logic, and so it must be one of these, right? But now we have assumed that pink and green are different, and now that is green, that means that have to be. But now see what has happened here, right? So what we have got is that um here pink is greater than green, and here green is greater than pink, right? This pink is on the green arrow, and here green is on the pink arrow. So that means if we go by this logic, pink is greater than green, and if we go by this logic, that green is greater than pink, right? So that's not possible, right? Either one of these must be true, but as per this, the both are true. So that means that our assumption, right, these two are different, that's not true. That means this is same as green. All the pinks are same as green. So we can convert all these to green. So all these greens are same. All right, you can change this also to not pink, green. Sorry, green. Yeah, so green is one of these three. Mm. Yeah, green cannot be here, right? Because now this is on the V, and V means this should sum to 5. Oh, okay. Uh, yeah, that is the other point I should have discussed earlier. Okay, so if you look at this arrows, right? Circle arrow. Now look at this arrow, right? Or this arrow, or whatever, the green arrow, right? It contains at least 3 digits, right? In this, and that means what is the minimum digits that could come onto this arrow? That's 1 2 3, right? Minimum the three digits that can put is 1 2 3. That means the sum is 6. So this must be more than 6 7 8 9. Okay, so all the greens are definitely more than 6 7 8 9. Okay, because if this is 5, this arrow is not possible. Three digits which are looking at each other with giving the sum 5 is not possible. The minimum you get is 6. So that means this is 6 7 8 10. And now about v, right? On v, you cannot put anything which is more than 5. The other digit will be either 0 or negative. So on v you can only have small digits, but now we know that this green is 6 7 8 9. So where is this green here? The by Sudoku logic green must be here, but it cannot be here. That means green is only one of this. And now you can see that by the x wing logic. Now what is the x wing logic? So we know that this green is only one digit, right? And in these two columns, it could occur only two times, right? But look at this. If green is here, then green will be here, and if green is here, then green will be here. Because in this column, it will be only in this in this row it will be only here, and in this row only here. So if this is here in this row, it will not be here. um, it will not be here, and that means in this row it will be here, and vice versa. That means even in this column it would be here and here. Okay, so this is called as x wing, but the implication is that that green cannot be here, and that means this has to be green. So that's a classic x wing logic there. Classic Sudoku. Classic in the sense the logic that is used in the classic Sudoku. Classic Sudoku means again, okay, I'm using all these words. So classic Sudoku means again the Sudoku where it's only numbers are given, and there is no other invariant Sudoku. It's only pure, only one rule, that normal Sudoku rules apply. Uh, so with that, yeah, with that now let's start coloring this. So what we will do is that we will now divide the grid into uh, into two regions. One regions being the digits which are less than 5, and the other region where the digits will be 5 or greater. So as you can see, right, all these are now uh, sum to 5. So now this could be only 1 2 3 4. It cannot be more than 5. So we can color all those green, and that means all these, right? So on x now, think about this, right? This is less than 5. So this both should sum to 10. So this will be definitely greater than 5, because otherwise two digits which is less than 5 can never sum to 10. So all these are greater than 5, and we can mark them using this one. And definitely 5 is one of these, because 5 you cannot have on x. The other way, other digit will also be 5, and 5 you cannot have on v, because the other digit will be 0. uh, so look, we got 4 here, right? That means this both must be 5. In fact this is high, right? But let this be green. We keep that. Maybe we can put 6 7 8 9. Yeah, in fact, let's do that reduction right away. See, these three digits, right? Now they minimum should sum to 6, and this will minimum to 1, right? So together, if you see that, right, they minimum should sum to 7. 1 2 3, which is 6, and then that is 7. So basically this cannot be 6, this must be 7. So we can reduce 6 from all of these. Now again look at this digit, right? Now this digit, what is the minimum sum of this? This will be 6, right? 1 2 3. So what will be the maximum digit on this arrow? It could be only 3, right? Because this could be maximum 9. This is minimum 6, so this could maximum be 3. That means this is low, and by the symmetry logic, right, this will be low. The other thing to notice is that the puzzle is quite symmetric. That means anything we do at one part of the puzzle, we can do also at the other part of puzzle. So even kind of eyes are also symmetric, right? The same thing goes with here, right? Because this was on the row. These are on the house, right? All these three are looking at each other. They will be minimum 1 2 3, and that means this will also maximum 3. So these are 1, 2, 3, and cannot be more than that. Anything else we can do? Okay. Other thing is here, right? Where is this digit in this, right? Now this digit cannot be here with the Sudoku logic. It cannot be here, and then it cannot be there on this arrow. So this digit is somewhere. So let us have this red. So red is somewhere here, and here also maybe we can use which color should we use now? Yellow. With the same logic, now this digit is not here. It's not here by the region logic, and it's not here by the arrow logic. So this yellow is now one of these. Mm. Yeah, now let's start using some letters for this. So let me enable the letter tool. I'll use this outlines on element. Something has changed, right? Suddenly. Oh, okay. This is good. This becomes suddenly dark. Uh, I'll mark check pencil mark off, and in advance I'll do that. In advance I do something, right? Not advance. Sorry. In experimental, there is this compact pencil mark. So I make this one. Okay, so yeah, so now that we have enabled letter tool, what we'll do is that we'll use the letters to denote the digits. So we'll use this A and we'll this use this as a B. So that means between A and B there is some relation, and that relation is that A plus B is equal to 5. So wherever we have this digit A, right, all those will be the same digits. Uh, Here also we can do this is C, this is D. Now considering this C, right, this must be AB. This cannot be CD because this is on 5, right? So C and D sum to 5, A and B sum to 5. Now this AB means this should be CD. This C means this should be AB. Because again this is 5, so it could be either AB or CD. But considering this C, it's not here. And similarly here, this is AB. Now imagine this is A and B, then these both will not be possible. So that is CD. Mm. Yeah, even this is high, right? Because now this is looking at both A, B, C, D. Now A, B, C, D are all the low digits that you have, right? You cannot have any more. So any cell which is looking at both A, B, C, D, that could be high. So this is definitely high. Even these are high, right? Because these are looking at A, B, and then C, D. So that means no low digit could come here. Only high digits could come here. Right. Now let's extend this. So now we'll say that anything on X which is opposite of A is E. That means E plus A is 10. So similarly for B we will use F, for C we will use G, and now here we will use H. So this is 5H. We can remove this pencil mark. So now between D and H the relation is that D plus H is 10, because all the other letters are 1 which are in 10 relationship. Clearly D and H must be 10, and 5 is here. Now AB, right? This must be one of CD, and this is D. That means, oh, this is C, right? This is clearly C because this is D, and this is looking at both AB. So that means this has to be C. Right. Now we have to think about where is B in this region, right? Now this region must contain all the digits, right? So it must contain A, B, C, D. Now where it could B come here? So B cannot be here by the Sudoku logic, and B cannot be here. So B cannot be here by the Sudoku logic, right? And sorry, B cannot be here, and also B cannot be here because A, B is here. So B is here. So the only possibility for B is here, right? In this region, B. Okay, just give me some time. I think there is some slowness in. Yeah, I hope it will be better now. I just close all the other tabs. Alright, so where we will A, B, and C, D, and we just mark E, F. We mark C, right, and we got D here. So by the same logic, where is D here? So D is not here. D is not here. So D must be one of these. Right now, you have to think about this digit, whether this is high or low. See, we already have DC here, and D plus C is 5. So we already have 5 here, right? So you cannot have any more highs here. Otherwise, the minimum high you have is 5, and then DC, which is already 5, plus 5 will be 10. So that is definitely low. Unfortunately, we cannot use this logic yet here because we do not have B and A here. We only have CD. So that could be C. No, that could be. Yeah, could, right? Because this is C or D, right? No, this could be high also, right? Yeah, this could be anything. So this could be C, this could be C, and then this could be high also. So this could be 5, and then these 3 could sum to 4, which is 1, 1, 2. That way it's possible. So D is one of this. Oh, but that is low, right? And that is again looking odd, A, B, C. So that means that has to be D. No, that's not low. I just said that, na, that cannot be. That's not necessarily low. But anyway, coming here. Wait, the thing is that, na, this cannot be AB now, right? Because if this is AB, we know that AB is itself 10, CD is itself 10. So that cannot be AB. Because then AB will be 5, sorry, not 10. AB is 5, DC is 5, and then together they will be 10. But that's not possible. So this is not AB. A is not here. And again, so A is not here and both are low, right? So that means D cannot be here, C must be here. And where could C go? That's the only place for C, and that's the only place for B. Oh, this is some this is some nicely built Sudoku. This is DH, right? Because this is on X, and it cannot have AB, it cannot have C, so this must be DH. And now we know that all this must be high because all AB series are done here. All this must be high. No, B is already here. B is already here. C. AB. Oh, we saw that, right? D is one of these. A, B, A, B, C. So A is not here. A could be here, right? This could be D. This could be A. But if this D, this is C, and that will be, that is A. That's not possible, right? If this is A, if this is A, this will be D, that will be C, and then again you have the same problem, right? So this is not A. This is not A. A could be here or A could be here. Okay. Let's think about this digit, right? Whether it is high or low. This one, right? Which is on arrow. Now imagine this is low, right? If this is low, this will be A because there is no other digit here. So this will be A, and then this will be B. So that means the sum will be 5, and that this must be between 1, 2, 3, 4, right? So that means this will be low. But imagine this is high. So if this is high, this will anyway it will be low because this is minimum 5, and whatever this is, this sum should be less than 4. But so irrespective of this is low or high, this must definitely be low. Yeah, where is A on this region, right? Where is A on this region? That is the question you have to ask. Where is A on this region? A must be one of these, right? Because now A is not here, right? That's definitely more than 4, and A is not here because of AB. So A must be here. In fact, that is now low. We proved that that is low. So that's CD, right? Can we prove the same thing here? I think we can, because if this is low, that will be C, right? Yeah, if this is low, we already have A, B, C here. So if that's low, that will be D, that will be C, and that will be anyway 5 plus something, which is low, and if this high, that's anyway low. So this is definitely low, and this is AB because we already have CD here, we have AB here. Uh, where is C here in this region? So CD, because C is not here, C is not here. C must be here, right? See, C must be here. That is clearly, this turns out to be CD. Okay. So this turns out to be CD. But C is looking at this, right? So that's D. In fact, that's low. So that turned out to be low. So that's low. That's C. Come on, man. That's C. And now because of this D, that's C. So now we have all the ABCD, right? So all these must be high. That's we are using for high, right? Uh, 1, 2, 3 high certain A, B, C. A, B, A, B, C. So we have DC here. So AB is remaining here, right? So where is B? B must be somewhere here, right? In this region, B must be here. Oh, so that must be A, right? Because of this B. Now that must be A, right? So that's B. That's A. That's B, and that's not B. And that means this is also high. And now we got all the highs here, right? In fact, A, B, C, D is remaining here. A, B, C, D. Oh, all these are high, right? All the A, B, C, Ds are done. So all these are high. Yeah, all these we already. B is one of these. A is one of these. A, B, C, D. Oh, so now where is A here? Again, you have to ask this question. Where is A in this region? It's not here. It's not here. A must be somewhere here, right? So that means that's not A. That must be high now. Okay. That's not A by Sudoku. Yeah. Yeah, this is important, I think. See, we know that this digit is one of these, right? Um, but both of these are low. That means this has to be low, isn't it? And now what is the only low digit that is remaining here? That's A. So that has to be A, right? Because we know that both of these is low. This must be low. But then it cannot be BCD. That has to be A. And now look at this. Where is the A possible here? We know that this is yellow, one of these. So that has to be A. That has to be B. We can remove the yellowness. Both these are low, so we can remove the halfness of this. Similarly, we can use the similar logic here. Yeah, both these are low, right? So this must be low, and with this low, the only remaining is A. So this must be A. And now where it could be A could be only here, which is already there. So yeah. But we can remove the redness, right? Yeah, let's remove the redness and let's make this fully blue. So these both are high now, right? Why did I put this high? That's low. Should I pacing mark everything? 5EFH, right? Hmm. That's not it. So should we try Sudoku to see if A is placed everywhere? That's A. That's A, right, by Sudoku. one of this is A and one of this is A. What about B? B is dot is remaining. That's high. Let's just put that that's high because it is now seeing all A B C D. C C C is one of this. C is one of this. Not much in C because of these sides. Yeah, because of this CD will be difficult. Even this CD, right? This DH. So yeah, we are not sure whether if that's the that C, but if that's H, you don't know. Right. Now the next thing we have to do is we have to figure out which one this digit is. It is high and it is not 5, right? So it must be one of E, F, G, and H, which are the 10 counterparts of A, B, C, D respectively. Um, so we have to figure that out. So look, I mean this cannot be E because E is looking at this, right? Here, so it's not E. It cannot be F because F is looking at here, and then it cannot be H because look, good, this H is looking at it. That means this has to be G, and G is 789. So let's put that this has to be G, right? But we know that G is here. That means now we can mark it as fully green. We can remove this greenness. We can mark now this as green because this cannot be green. So let's do that. This is not green. This is fully high, and this is green, right? So this green means this has to be G now, and that means that's A, which is we have pencil mark earlier, and that means that's A. That's not A. Both these are now low. That's not H, right? Because H is already there. In fact, those all are 5, 5EF. 5H, 5H, right? Now this must be EF, right? 5H. We can remove 5H from both. H5. That's EF and that's EF. So that's 5 now, right? That's the first digit that we got. That's 5 because both this EF are looking at that. So that's the first digit we got. And now this must be H because that's the only remaining here. So that's not 5, right? EF, EF. Now look in this region, right? So this region is same as any other house. So we got 2 EF. So none of this should be EF. So we can remove EF from here. So we got 5H. EF, 5H. G. Now do we have anything with D? CD, CD, okay. A. So we got one relation, right? G is 2C plus B plus B, and we need to have this one. There could also be this, but I think it's difficult because of C and D. And CD are not getting resolved. At least not yet. Yeah, let's go ahead. So this is 5 and something, right? 5E, and that's also high. Let's keep going that with that. 5E. So now what is this 3? So that's DH, 5E. 5 is also gone. So that is DH and something, right? Not G, sorry. D, H, and what is remaining? Okay, D, H, and E, sorry. My bad. This is not E. E is already here. So this is 5 and F. Okay. Alright, and this is D, E, H. But that's high, right? So that cannot be D. Because yeah, D is looking at it. So that's not D. So DH, DH, EF, EF, 5EF, 5EF. That's 5H, EF, right? EF, 5. Oh, that's not 5, right? So that's EF, EF. So that means that's 5H, right? So in this box, where is 5H? That will be 5H. That means that's not H. What's remaining here now? CDEH. CD is remaining. But now we know that C will be one of these, right? So C is not here, so C is one of these. In fact, where is D? D is not here. Where is D in this box? Oh, that should have been thought of. Where is D in this box? D is only here, right? In this region. D is only possible there because D is not here. D is not here because of this CD, and D is not here because of this. That's the only D. And now see, we got another X wing of D. So D cannot be here. So that has to be C. That's C. That's not C. In fact, D is here, right? We know that one of these is this. So this high. Oh, see, some C is marked here. So that's C. That's not C. Let's mark this view. Oh, C is already there. C, 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 D. This CD is not resolving, and this CD is not D and 5H, EF, 5H. So D is here, right? 5F, EH, D. Right, now look. That's 5F, right? Here, okay, okay. F is either here. Where is F here? It has to be here, right? In this box, because it cannot be here. It cannot be here. F has to be here. EF, EF, 5H. 5H, 5H, EF, EF. These two is what? So D is remaining here, right? So D, E, F. So now think about this, right? This is 7, 8, 9. Okay. How can this be D? How can this be low? Because the maximum A can go is up to 4. And the maximum G is 9. Is 7. So how can this be low or high? Okay. If this is D, maximum this is 7, 9. That's fine, right? Okay. I should have thought about these errors first. See, look, now we have already talked that, right? D plus C is 5, right? But what is the minimum sum of D plus C, right? So minimum this will be 1, 2, and D plus C is 5. So that is it. So this cannot be even 7. So all these we can even remove 7 from here. Now just for the sake of completeness, let's put this as 8, 9G. You can remove A from there. Right. So now this is 8, 9. So now maximum this is 7, right? If this is low, that is D plus A, which is 7. But that cannot be 7 because now that is 8, 9. So this cannot be D. Now if this is E, right? We know that A plus E is 10. So this cannot be E. So this has to be F. And that means that's high. That means that's E. That's D. That's F. That's F. E is not helping anywhere. E is not here. Could be anywhere. Now this has to be F, right? It's the same relation, right? G is equal to A plus something. So that also has to be F. Where is B here? B must be one of these. And where is D here? Oh, D is only here now, here, right? Because all these are high. Or in fact, we can say that D is not here because of this, D is not here because of this. So that has to be D and that has to be B. Both these are low. That's clearly now high. Let's put that. A, B, C. D is one of these. Okay, so we can't make. Both these will be higher. A, B, A, C, D. Where is B here? B has to be here now, right? In this box, A, B, C, and that's D. I don't see anywhere D. B. B cannot be here because of this. B cannot be here. B cannot be here. Yeah, that's B. So have we done with all the B's? B, no, not quite, right? B is one of this and B is one of this. At least A we should be able to do, right? Yeah, A is we have done. C, this CD is remaining. So 8, 9, but that's not necessary, right? It depends on this number. In fact, considering this is minimum 3, this should not be more than 6, right? So both these will be 5 or 6. Let's put that there, 5 or 6. E, F, F, H. Now let's not do that. Let's just remember that, make a mental note that these are 5 and 6. Okay, I think we'll have to now look at these two equations. We got this, right? G is equal to this equation 2C plus B plus D and G is equal to A plus H. We know that C plus D is 5. We can reduce that G is equal to 5 plus B plus C. 5 plus B plus C. G is equal to 5 plus B plus C. G is equal to 5 plus B plus C. If you add C into both, right, what we'll get is G plus C equal to 5 plus 2C plus B. But G plus C is 10. So we will get 5 plus B plus C is equal to 10. Now you can remove 5 from both sides. We'll get B plus 2C, sorry, now it is 2C. B plus 2C is equal to 5. Right, we got that, right? B plus 2C is equal to 5. Right, let's put this as 5. B plus 2C is equal to 5 is what we got. Yeah, this one and this one. B plus 2C is equal to 5 we got. So what is the option for C? If C is 2, B is 1. If C is 1, B is 3. That's the only two options. Yeah, let's go with 1. If C is 2, B is 1, right? C is 2. Yeah, B is 1 because then 2C will be 4 and B must be 1. But if B is 1, A must be 4. Let's try out here, right? That's say we know that A must be 4. B we are seeing as how to remember this one. Yeah, let's get this right. Yeah, this is the row where we are trying everything, right? So let's try this. So we are saying that C is 2 and B is 1, right? So 1B, B is 1. Now A is 4, right? Because of that. But because now B is 1, F must be 9. Oh, that's not possible, right? 9 plus 4 will be G. So that's not the option. So B1 and C2 is not possible. Let's remove all these things. So B1, C2 is not possible. The other is C is 1 and B is 3, right? C is 1 and B is 3. So B is 3 and C is 1. So now if B is 3, A must be 2. A must be 2 and F must be 7, right? Because B and F has 10 relation. So yeah, this is fine, right? This is fine. So B plus 2C is equal to 5. We got that from this equation. What we did is that D plus C is 5, right? So B plus C plus 5 is equal to G. So if we add C into both sides, we'll get that 2C plus B plus 5 is equal to 10 because G plus C is 10. Now you can remove 5 from both sides, you get b plus 2c is equal to 5. And we tried b first with we tried c first with 2 and b1, but then f becomes 9, and this is impossible. Now 9 plus 4 will be a lot high number, anything, because a is not 1, right? So we know that this will be much more than 10. So the other possibility is C is 2, C is 1 and B is 3. Now we are trying that 3B. So F will be 7, A will be 2 and G will be 9, and this makes sense. Let's try this here, right? Is this working? Um, D plus C is still 5. B we have seen is 3. If B is 3, and C we have seen is 1, right? So D plus C 5, and this will be 4. So that will be 9, and this will be 9. Yeah, so that's fine. That's fine. So we got this. So let's yeah, mark this here only, right? So B is 3. We have seen that A is 2. So let's mark this as 2A. C we are seeing is C. Yeah, we can say that C is 1. Yeah, B is 3, right? B is 3, so C is 1, because B plus 2, C is 5. And if B is 1, then D is 4, 4D, right? If D is 4, then H is 6. We can put this H here. H is 6. Now, because D and H has got that relationship of 10. Uh, F is 7. We have already put it here. F is 7. And E is now 8, right? E is 8. E is 8. Yeah, so that should do, right? Let's go back to here. So that is A. That is F. Let's remove these things, right? This is one of these. So now what we can do is we can simply click something A, and we'll put 2 here. We'll click B, we'll put 3 there, right? We'll click C, we'll put 1 there. We'll click D, we'll click put 4 there. We'll click E, and we'll put 8 there. We will click F, and we will put 7 there. And G, oh, how can I forget G? G will be 9. Yeah, so that's how I think this is, and this should be now doable, right? Yeah, we let's do this also. So that's 2, that's 3, that's 7, that's 1, that's 4. Sorry, that's 4, that's 8, and that's 6, right? So yeah, 5H, 5H, EF, that will remain as it is. We don't know that yet. Yeah, now let's start replacing this. So this was 1 4, right? 1 4. Can that be 4? No, 4 2 will be 6, and that will be 3. So that's not 4. That's 1. That's 4, and this is 6, right? That's 6. That's also 6, right? With the same logic, not same logic, but with symmetry. These 3 numbers now we can put. This is not that must be 7 8 5, right? 5 7 8, but that's 5, so that can't be 5. What is this? Linked. Oh, I have to remove that. That's not. What is happening? That's not 5. Even that's not 5. So that's 7 8. So we got 7 8 7 2. What are these two? This must be 5 and 6, right? We know H is 6. I remember H from here. So H is 6. 5F 5F. So that's 5. F I remember is 7. So 5 7 5 7. These two, right? 5 7 and 8 is remaining. So 5 7 8. Now look, where is 6 here? So that has to be 6. So now can we do 6 here? Where is 6 here? Oh, 5 H. H I remember as 6, right? So that's 5 6. Yeah, H was here, right? 5 6. So now 6 is not here. 6 is not here. 6 will be still one of these, right? Let's remove this DH. Oh, but both D and H. Oh, H is 6, right? Yeah, but then again that could be 6. We don't know. We don't know. So let's remove this DH. Oh, instead of DH we can put 4 6 now, right? Directly, right? Because D was 4 and H was 6, so that we can do. And this we can remove, and we can put the proper numbers here. That's 1 2 3 4 6 we know. What is the other one? 8, right? 4 6 and 8, and yeah, this is not 6, and that's not 4. These two digits we already have 5 6 here, so 1 2 3 4 6 8, right? 4 6 8. Not 4 6 8, sorry, 4 7, but look, 7 is here, which is looking from here, so that's not 7. uh, and what's that now? Those are also 3 numbers which are 5 6 8, isn't it? Because 7 is already here. Oh, 7 is not here, right? Yeah, so now in this region, where is 7? In this region, where is 7? That's the only 7, right? So that has to be 7. 7, 7, that's 7B, right? Oh, I don't remember what was B. B was this guy, right? 3. Yeah, but anyway, 7. Oh, that's not 7. Let's start from there. So that's 5. So what are these now? These are 3 7. Okay, so that way I was correct. B was 3. This is now 1 2 3. Yeah, all the highs are done. So that means this is 5 and 8, right? 5 and 8 are remaining. Anything looking at this 5 8? No, not yet. 3 7? No, not yet. So now because of coloring, I was able to do first. This was 4, right? D was 4. I remember that. 5 7 8. These are both 5 7 8. I can already see that 5 7 8 here. B was 4, right? No, B was 3. B was 3. I don't remember. C was 1, right? Yeah, that's from where we started, right? C1, B3. No, 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 no. Let's not go there. Let's not go there. Let's do now using the Sudoku. So, yeah, so what is happening now? Yeah, this region, right? This region now definitely needs 6, right? And where is that one? That one is there. So that's 6. That's 5. And now this also needs 5, right? This region, so that must be 5, and that can't be 5. Now let's do reverse. So that's 8, that's 5. That 8 is not doing anything. That 5 is also not doing anything. That 6 is also not doing anything. Yeah, of course, this was 5 6. We already figured that out. Yeah, that 7 is doing this, so that's 3. That's 7, which was I think from earlier. But anyway, that's 8. That's 7. That's 8. 4 6 4 6 4 7 8. Okay. That's 6. Oh, that 7 is not looking at this. That's not 7. That's 5 8 5 8. So 7 is one of these. That's not 7, right? So 7 is not there. So where is 7 here? That's the only place for 7. And I think we have done with 7. Yeah, we have done with 7 except here. Why is that? Because that has to be 7, right? Yeah, we have done with 7 now. Those must be 4 5 6 8. No, this cannot be 6 now because of this. So that is 4 5 8. 4 5 8. And I can see that this cannot be 8. We can reduce that. 5 8 5 6 4 5 8. This is still not reducing, right? 4 6 4 8 6 8. This should be no, because of this is not possible. Okay. Let's come here, right? Oh, these 4 digits we should be able to do now. 1 2, that's 3 and 4. Oh, 3 4. Both low digits are remaining, right? 3 4. But look at that. That 3 is looking at this 4, so that is 3. And now that's somewhere there is 1, which is here. And now that must be 6, right? Now that 6 gives rise to 5 6. That 5 is 8. That's 4. That's 5. That 5 gives rise to this 8. That gives rise to this 6. That means that's 4. That's 8. That 4 must be again 6. That's 4, 5 and 6. 8 and 6 both looking at that. So that's 5. That's 8. That's 5, and that's how we have done the puzzle. Okay. Yeah, so I think this was a little bit complicated puzzle. I mean, not that utterly impossible, but these arrows, right? They were kind of complicated. You have to do all these kind of equations, and you have to do all these kind of substitution. Assuming, I mean, you have to run all those cases, right? What should happen, and then these kind of tricks were there. But anyway, I'm not sure how this puzzle was thought. I think that there could be some better way, because I was putting the letters and then I stopped midway, and then I start thinking about this, because I could not go anywhere just with the lettering. So that's why I thought that it should be it. Or maybe it is possible that I should have been starting uh, putting the numbers earlier. I could, but no, I need two equations, right? So either this was the one equation, this is the other, and this is the other. Maybe this equation could have been also used, but we didn't know that. No, right? Oh, this we know, right? A plus C was there, and this was 5 6, and this is G. Maybe that along with this we could have used to get the faster results. Yeah, but anyway, that's the puzzle, and I'm really happy that I'm able to solve this. This was quite complicated, I think, because earlier you have to also use this logic to prove that everything is same, and then one by one, using the letters, you start filling up the space, marking highs and lows. So this actually uses all kind of tricks in this puzzle. So anyway, that's the puzzle, and I hope you guys are also like this puzzle, and I hope this person, right, MS-DOS or Matt Trezel, will come up with some more interesting puzzle in future. So yeah, so that's all. Thank you guys. Thank you very much.